Okay, guys, so let's get started without any further ado. In the last class, we covered a few important concepts in networking. So we were talking about the different classes. We talked about, if I remember correctly, we talked about the sequence of IPs, the classification, what are public IPs, what are private IPs, okay, and what are the ranges of these IP addresses. What does class A signify, what does class B signify, and what does class C signify. We talk about the difference in each class. Okay, today we're going to learn some more advanced concepts such as subnet mask and a few important protocols like DNS protocol and DHCP protocol. So first things first, what is the subnet mask? So when I open up my command prompt, and in my command prompt, when I search for ipconfig, this shows me my private IP address. So right now my system, my laptop on which I'm conducting this session is getting the private IP of 192.168.0.5. Okay. Now looking at this number, we exactly know that this IP belongs to class C because we covered the ranges of IPs in the last class. Okay, what is the range for each specific class? So looking at this number 192.168.0.5, if you remember the range from yesterday from this table, we can figure out that this IP belongs in this category of class C between 192.168.0.0 and 192.168.255.255. This is the private IP range in class C. We covered that yesterday. I hope you recall. Now, below that, if you notice over here, if I go back to that command prompt, okay, so if I go back to my command prompt, you would notice just below my IPv4 address, we have another value called subnet mask. And for this address, it says the subnet mask is 255.255.255.0. Now, what is the subnet mask and how are we getting this value 255.255.255.0? Now, the subnet mask is for the computer to understand which IP belongs to which category or which class. Okay, we humans can easily understand each difference in class with the network and host portions. We define class A with one network portion and three host portions, class B with two network portions and two host portions, and class C with three network portions and one host portion. But how does a computer differentiate that? How does a computer know which portion is the network portion and which portion is the host portion? So for that classification or for that differentiation between a network and host, what a computer does is it assigns the value of 1 to the bits of network portion and the value of 0 to the bits of host portions. So when we talk about class A, where it has one network portion and three host portions, in the first portion you have all ones, okay, and in the remaining three portions, which are host portions, you have all zeros. And when we convert this number with all ones and all zeros to decimal, all ones gives you 255 and all zeros simply gives you 0. We learned about this in the first class, how to convert any binary number to a human readable decimal number. So for class A with one network portion and three host portions, the subnet mask is the value 255.000. Okay, so wherever there's a network portion, there's 255, and wherever there's host portion, there's simply 0. So 255.000, a subnet mask of this a subnet mask given to this any random IP of this value indicates that it belongs to class A. When you go for class B, which has two network portions and two host portions, they're all ones in the first two portions and all zeros in the last two portions. Therefore, the subnet mask is 255.255.0.0. So if you see an IP address with the subnet mask, it indicates that that IP belongs to class B. And finally, when you come to class C with three network portions and one host portion, the subnet mask is 255.255.255.0. And if you notice, this is the same exact subnet mask that we observe over here below 192.168.0.5. Since this is a class C address, the subnet mask for that is 255.255.255.0, exactly which is shown over here. Okay, so that is how a computer knows if that is a subnet mask, it belongs to so and so class, and these many devices is what I can connect with. So once it knows the subnet mask belongs to class C, the computer knows that it has a limit of maximum 255 devices, not more than that. Because in class C, the maximum devices you can connect is 255. Okay, we talked about that yesterday. Okay, and below subnet mask, you have another value called default gateway. Now this is your router's address, guys. So your router is called as a default gateway in your network because that is the default device to which you send any packet, okay, where it needs to go out of the network. So a router acts as a gateway between the private network and the public network, and hence the name default gateway. Okay, and it always gets the first IP in the network, 192.168.0.1. That's the first IP assigned to the router. Okay, any questions, guys, up to this point? Ashish, Lakshmi, Kripa, what is subnet mask and what is default gateway?
No, sir.
No. Not good.
Lakshmi, were you there in the class yesterday? I cannot
Yeah,
recall.
I was
Oh,
there.
right, you were there,
So
right? Okay.
Yeah.
Yeah. Right.
actually, I joined today from my side. I am the new student.
Oh, okay, Ashish. No worries, Ashish. All these classes are being recorded and they're being uploaded on YouTube, if I note correctly. So again, if you want the older recordings, you can just go to DURGASOFT channel on YouTube and search for cybersecurity. So all the classes that I've held from this Sunday are actually being uploaded day to day. So you can
Okay.
you can find all the recordings up to yesterday's class if you go and check now. Okay. And this
So
class will also be recorded, obviously, given some time. Yeah, Ashish, go ahead.
yeah. So I just want to know that how many classes are over as of now,
We
as of today.
started the classes from Monday. So Monday and Tuesday, 2 classes are done. This is
Okay.
our third
Got.
class.
Yeah.
Sunday I
It's
just
fine.
took Sunday I just took a workshop, a brief
Hmm.
introduction or a demo class to give you a brief, on the all the course contents. But the actual classes started from Monday. Okay.
Yeah. Got it.
Right. Now, moving on, after subnet mask, we have to talk about how to assign a private IP. So again, there are two methods, guys, of how to assign a private IP. So you can either get it manually, you can assign it yourself manually from a control panel, or you can get it automatically from something called a DHCP server. So we'll go with the automatic method later. Let's go with the manual method first. How do you manually assign a private IP to any system? Okay. So there's a certain procedure for it. So in order to assign the IP manually, you first you first have to go to control panel. In control panel, you would select network and internet. In network and internet, you go for network and sharing center. Then you go to change adapter settings. Then you right click on whatever adapter's IP address you want to specify, you want to modify or specify. And then you go to the properties of it, IPv4 properties of it, and then you specify the IP address. Okay. So if I show you the same exact procedure practically, I'll go to my control panel here, or I can search for control panel. Click on control panel here. In control panel, I go to network and internet. In network and internet, I go to network and sharing center. In network and sharing center, next thing to do is change the adapter settings. So on the left panel, you see there's change adapter settings. Click on that. Now with that, you see a list of all the adapters here. And then you right click on the adapter for whichever you want to specify or modify the IP address. So I right click on my Wi-Fi adapter, let's say, and here I go to properties. Once I'm in the properties, I can see a property called IPv4, Internet Protocol version 4. I select that and click on properties again. So this is how you get the settings page to modify the IP address. Now, if you carefully observe here, there are two methods. One, I can obtain an IP address automatically. So that is the DHCP server method. Right now, my system is getting an IP from a DHCP server. But if I want to assign an IP manually, I have to go for the second option. So I select the second option here, and I can specify the IP address of my choice. Right now, my system is getting the IP of, if I open up my command prompt and if I run ipconfig, right now my system is having the IP 192.168.0.5. Okay. Now, if I want to modify that, if I want to give another IP, let's say 192.168.0.100, I can specify that IP address here. Okay. But please note that whatever IP you're specifying here, it belongs to the same class. If you modify the class, you have to modify the settings in your router as well, just so that your router and your system can communicate with one another. So right now, I'm specifying the IP from the 192.168.0 network itself. I'm just changing the last portion, the last octet from 5 to 100. Okay. Now, since this is a class C address, subnet mask is 255.255.255.0. So when I click over here, it automatically gets assigned. So it knows 192.168 is class C. So it assigns 255.255.255.0. Okay. And default gateway is your router's IP. So you can just specify 192.168.0.1, the first IP in the network. Along with this, you also need to specify something called DNS server addresses. Now, if you don't know what DNS servers are or what IP address to assign here, nothing to worry. First, let me tell you what addresses to assign here. Later, we'll talk about DNS servers as well. So for now, if you just don't know what address to assign there, go to your browser and search for Google DNS server IP. And this is going to provide you two IP addresses. One is 8.8.8.8 and the other one is 8.8.4.4. And you can specify any one of them. So you can go back to your control panel and again use those IPs here, 8.8.8.8 or 8.8.4.4. Even if you specify any one of them, that is good enough. Okay, so once all these properties have been configured properly, you just need to click on OK. Now, since I'm specifying a different IP, guys, since I'm changing my system's IP, we might get disconnected from the meeting for a very short duration, but don't worry, we'll connect back automatically as well. Okay, so again, don't worry if the voice gets cut off, the screen stops sharing. So we'll automatically connect back to the meeting in a minute. Okay, so once I click on OK and close, I should have been reconnected by now, guys. If I go back to my command prompt again, and now if I type ipconfig one more time, you would notice I'm getting the new IP address 192.168.0.100. So this is the newly assigned IP address to my Wi-Fi adapter. So again, in the olden days, guys, when you were assigned the job of a network admin, it was your responsibility to go to every system in your organization and assign an IP address this way. Okay, again, this is the manual method. But if it's a small organization, there's no problem with this method. You can go to 10, 20 devices, assign a unique private IP to every system. But if let's say if it's an MNC, if it's a multinational company, and let's say there are thousands of devices in your network, in such a scenario, you going to each system and assigning a private IP is quite a tiresome task. It's not so easy. Okay, that is why they came up with another alternative, a much more easier alternative called the DHCP server method. So there is a server called DHCP, which stands for Dynamic Host Configuration Protocol. So if I just write it down somewhere, it's called as Dynamic Host Configuration Protocol. And from the name itself, you can figure out what it does. It is used to dynamically or automatically configure an IP address, an internet protocol address, to every host in the network. And this happens with something called the DORA process, guys. Okay, so with just one single click of a button, my system can automatically retrieve an IP address from a DHCP server. So I just have to go to my adapter properties, and in properties, I go to IPv4 properties, and I just have to select this first option, obtain an IP address automatically, obtain DNS server automatically. And with just these two clicks of buttons, my system will automatically retrieve an IP address from DHCP server. Let me show you that. So if I click on OK, and if I go back to my command prompt, command prompt, and if I run ipconfig again, earlier I was getting the IP 0.100, but if I hit enter, you can see I got my 0.5 IP again. Okay, so the main question is, how is this being assigned? How is my system automatically getting this IP 192.168.0.5? What is this DHCP server? Okay, so as mentioned, your DHCP server in your network is used to automatically assign an IP with something called a DORA process. So no matter how many devices are connected in your network, all the devices retrieve an IP from the DHCP server, okay, with the process called DORA. So your DHCP server always has a pool of free IP addresses. So if your DHCP server gets the first IP, the remaining IPs are present here as a pool of, again, it is allocated the list of all IPs. And from that list of IPs, from that pool of IPs, it assigns each system a unique IP in the network. Okay, and that assigning part is done with the DORA process. So let's talk about this DORA now. So let's assume in your network now, there's a new system and there's a DHCP server here. Okay, now whenever there's a new device connected in the network, and when this device is again trying to retrieve an IP, first thing that this device does is it broadcasts a signal. So what I mean by broadcasting is, from this device it starts sending a packet to every other device in the network. So if I draw this out just a second, so if we take the scenario here, let's assume this is a DHCP server here. Again, this is a system in my network, a newly connected system. Let me call this as DHCP server. So in our home networks, guys, our Wi-Fi router itself acts as a DHCP server. So that's why it gets the same IP as the router, 192.168.0.1. Okay, and then it has a pool of IP addresses, pool of free IPs. Okay, so from the next IP, 192.168.0.2, 192.168.0.3, 192.168.0.4, like that, it has a pool of free IPs till the last IP. Let's say 192.168.0.254. Again, an important point to note, guys, these two IPs are never assigned to any system. 192.168.0.0 and 192.168.0.255. These two IPs are never assigned to any system. Reason being, this first IP is called the network ID, and the last IP is called the broadcast ID. Again, network ID is to identify the network. It is never assigned to any system. And broadcast ID is something on which if you send a packet, it is sent to every other system in the network. So for example, if there are other systems in my network, let's say there are these three devices here. Okay. And if these three devices have IPs, let's say 192.168.0.2, let's say this is 192.168.0.3, and this is 192.168.0.4. Let's say they have these IPs. Whenever these IPs are assigned to a system in the pool, they are removed again. So now your pool begins at the next IP. Oh, my bad. Let me erase this one. Oh, it's erasing the whole thing. Anyways, so your pool now begins at the next IP. Pool of free IPs starts at the next IP now. So again, the new IP would be 192.168.0.5, then 192.168.0.6, then 192.168.0.7. This goes on up to 192.168.0.254. Okay. Now, whenever there's a new device in the network, let's say this is the newly connected system. Now, this device starts sending a packet on every other device. How does it do that? It sends a packet on the broadcast ID 192.168.0.255. So when that happens, what happens is, when that device sends a packet on the broadcast ID, the packet now reaches to every other system in the network. Okay. So this is called a broadcast signal. And this packet is called the discover packet. So basically it is trying to figure out where is the DHCP server. It's asking every other system in the network. Are you the DHCP server? 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 When it reaches the wrong devices, they just cancel that packet. They don't respond to it at all. So they just drop it. Okay. They don't respond to it at all. But when it reaches the correct DHCP server, that server responds back. It says, hi, I'm the DHCP server in this network. You were looking for me. So again, I know I can figure out you're new to this network. So I can offer you an IP address. So now an offer is initiated. Oh, 1 second, guys, it's not visible properly. Yeah, much better. So now an offer is initiated with the available IP in the pool. Next available IP is 0.5. So this available IP is provided to that system. Okay. So when that offer is made, your system says, hi, thanks for reaching out to me. Thanks for providing that IP to me. What I want you to do is I request you to allocate that IP to my system. Do not assign it to anyone else. Since I requested it first to you, you allocate it to me. So that request is sent from a client to the server. And for that request again, your DHCP server acknowledges it. It says, okay, I have got your request. And now with the final packet called the acknowledgement packet, I assign this IP to your system. So this last packet is called the acknowledgement packet. And with this acknowledgement, your system now gets the final IP 192.168.0.5. So now this device gets the new IP 0.5. And as soon as that IP is assigned over here, that is again removed from the pool. So the pool does not have this IP anymore. Now the new pool begins at 0.6. Okay, so this is the DORA process, guys. D for discover, O for offer, R for request, and A for acknowledgement. Okay, so your client first sends a discover packet, your server responds back with an offer, it sends a request again and receives an acknowledgement. And with that, a new IP is assigned to the new client. Okay, and all of this happens in a split second, guys. I'm pretty sure you must have observed this on Android phones. So whenever you connect your new Wi-Fi and when you enter the password, after that, when you click on connect, for a very short duration, you get this message obtaining IP address. Not sure how many of you have ever observed that, but during that process, your phone is connecting with the Wi-Fi router, or which is also your DHCP server, and it is trying to perform the DORA to get an IP. Okay, so this is the whole DORA process through which any system in your network automatically gets an IP address. Okay, is that clear? Any questions? Ashish, Lakshmi,
No.
Kripa,
No, sir.
Atish. Okay, right. So moving on to the next protocol, guys, we have something called the DNS protocol. So let's talk about that now. Okay, so if you remember in the manual assignment, it was asking us something called DNS server IP. Okay, so what is this DNS server now? Okay, so when you talk about DNS servers, guys, these are like something like the contact book for your internet. or the phone book for your internet. Now, what do I mean by that? Okay, so if you open up your Android phone or your iPhone or whatever it be, you have an application that called Contacts. What does that Contacts application do? It links every contact name with a contact number and vice versa, right? So we humans are terrible at remembering huge list of numbers. So again, if I ask you a question, like give me the contact name, the contact number of so and so person without looking, you might hesitate a bit, okay? Because in your phone you might have 200, 300 contacts or so, and you can't remember all of them. Definitely, it's a miracle if someone does remember all the numbers in their phone. I rarely think it's possible, but again, it's just so that it's made easier for us. What do? Is we search it by the contact name. So again, if you have hundreds of numbers, you don't have to remember each number. You search by the contact name. Okay, so you would search with alphabets A, B, C, D, or whatever it is. So when you want to dial up my number, you would search SHOA so and so, and you find my contact number. And when you click on that contact name, it dials to my exact number. So that application, the contact book application, is linking a contact name with a contact number. Okay, so now your SIM card has no relevance with what you're saving the name as. It is only the only thing that is required for it is its own 10-digit SIM card and the target 10-digit SIM card to make or initiate the call. Okay, it is not relevant for the SIM card what you save the contact name as. You can save it as Shoaib, you can save it as CyberSec Trainer, you can save it as DURGASOFT Cybersecurity. Doesn't matter what you save it as. It dials the 10-digit target number, right? Similarly, in your browser, when you open up a browser and when you search for www.google.com, your browser actually doesn't understand this language. It doesn't know what www.google.com means. The reason being, whatever traffic flows on the internet, it flows through the public IPs. So when you're connecting to Google, your browser only needs two things. What is its own public IP and what does it need to connect to? What is the target public IP? So this google.com must be hosted on a web server. That web server might have a public IP. So the only thing your browser needs is that target public IP. Okay, but where does it achieve that? It achieves it from something called a DNS server. Okay, a DNS server is something like the internet's phone book, where it has a linking between every domain name and its linked IPv4 address, IPv4 public address. Okay, so if I show you this with the diagram here, as you can see, in your browser, when you search for google.com, that request first comes to your router. From the router, it goes to your ISP. And in your ISP, they have something called DNS servers. And in those servers, they have the linking between every domain name and its corresponding public IP. And once it knows when you're searching for google.com that this is the IP it has to reach out, from there, it reaches that target domain, okay, with that exact IP. Okay, and this is what a connection occurs like, or looks like. Okay, so you type a URL in your browser, that URL is converted to its exact public IP from DNS records. And from that public IP, it reaches the correct server. If you don't have a DNS server, none of your websites will get resolved to their exact public IPs. So this acts as a phone book for your translatable, readable, or human readable domain names into its exact IP addresses. Okay, and vice versa. If I show you an example for this, I can go back to my command prompt here, and I can run a command called ping www.google.com. Ping is a command to check for connectivity. It uses something called ICMP protocol to send some packets to the target and receive responses as well. So when I hit enter, right now my system is sending some packets to Google, and you can see I've got responses as well. So it sent 4 packets and it received 4 packets, and there was 0 packet loss, which means everything is perfectly fine. And if you notice over here, when I'm pinging to Google, I get a certain public IP, 142, 250, 195, 132. If I copy that IP and if I go to my browser and if I paste that IP here, carefully observe what happens when I hit enter. It loads the exact google.com website, if you notice. Okay, so actually when you had to visit Google, you have to remember this IP, guys. Okay, if there were no DNS servers, but with the help of a DNS server, it is linking this domain name with its exact public IP. Now we don't have to remember these random numbers. We can just remember the name, domain name, google.com. Okay, so again, brief recap: a DNS server is the internet's phone book, translating human readable domain names into IP addresses and vice versa. Okay. So whenever you initiate a request with a domain name, that always reaches a DNS server, where in the DNS server, that domain name is converted to the exact public IP of the server on which that website is hosted. And from that, it reaches the target web server, the intended web server. Okay. Is that clear? Kripa, Lakshmi, Ashish, Atish.
Yes, sir.
Yes.
Perfect.
Yes.
Atish, can you hear me? I guess you have joined a bit late. Did you join the earlier sessions by any chance, Atish? Or is this your first session? No. I guess Atish is away from the keyboard. Anyways, moving forward, guys, as mentioned, these are two important protocols to know: DHCP protocol and DNS protocol. In real time, they're used in every organization, frankly speaking. So moving on to the next topic, we have something called special IPs. Last topic for the in networking class. Okay, so in your whole IPv4 range, guys, from 0000 to 255.255.255.255, you have two special IPs in them. Okay, so there's something called as loopback IPs and also something called as APIPA. So these are neither public IPs nor private IPs, guys. Okay, so they're not used for connecting with other systems. They're only used for troubleshooting of your system. Okay, so firstly, when you talk about loopback IP, they range from the number 127.0.0.0 all the way up to 127.255.255.255. So the whole 127 dot range is given for loopback. Again, this IP serves only one single purpose, guys, to check if your NIC card is functioning properly or not. Now, every device has something called NIC card, network interface chipset card. Again, this or network interface controller as well, the network interface controller card. This is responsible for all network communications on your system. So if I go to my browser, and in my browser, if I search here for NIC chip or NIC card, this is what it looks like. So on your laptop or on your computer, whenever you have an Ethernet port, right beside the Ethernet port is what you have the NIC card. So all the network related components are again assimilated on this one single chipset. Okay, and this is the main chip responsible for all network communications. It has the Ethernet port connected on it, the Wi-Fi chipset connected on it, the Bluetooth interface connected on it. So whatever networking related components are there, all of them are put or accumulated on this one single chip. Okay, and if this chip fails to function or if this malfunctions, your system will not be able to retrieve an IP address. And when it is unable to retrieve an IP, it will not be able to communicate with any other system as well in your network or external networks. Okay, so if you want to verify if your NIC card is working properly or not, all you have to do is ping on the loopback IP. Okay, so the loopback IP is the IP assigned to the NIC card. So if I open up my command prompt and if I type ping and any IP starting with 127, let's say 127, 50, 60, 79, any random IP, and when I hit enter, you can see I'm getting a reply back, which indicates my NIC card is pinging back to me. It's replying back to me. So since you're connecting to your own device, hence the name loopback. You're trying to connect to your own system. You're talking to yourself. A connection is looping there. Hence the name loopback IP. Okay. So again, this is only used for one single purpose, guys. Check if your NIC card is functioning properly or normally or not. Okay. So you can ping any IP starting with 127. So I can give 127, 255, 255, 254, and I still get the same output. Okay. That is just pinging to my system and letting me know that the NIC card is working properly. Okay. So again, if you were to ask me, definitely this is a wastage of IP addresses. Okay, and this was resolved in IPv6, the much later version of IPv4 addresses, but that's a topic for another day. Okay, so loopback IP serves only one single purpose, to check if your NIC card is functioning properly or not. Moving forward, we have something called APIPA. It stands for Automatic Private IP Address Assigned. Okay, private IP assigned. Okay, now this ranges from the number 169.254.0.0 to 169.254.255.255. So any IP starting with the first two octets, 169.254, stand for the APIPA IP. Now this is a very special case IP, which is assigned to your system when it is unable to retrieve an IP in both the methods. So if you remember, I've shown you two methods to assign an IP. One, manual method, and two, automatic from a DHCP server. So in a scenario where your system does not retrieve a private IP from both manual methods or even from a DHCP server, in such a scenario, the operating system itself, the Windows operating system or the Linux operating system or the Mac operating system, doesn't matter what operating system, the operating system itself assigns an IP, and that IP is called the APIPA IP, starting from 169.254.0.0 to 255.255. So this IP is not used to connect with any other system, guys. This is just to indicate to you that your system is unable to retrieve an IP from any other source. That's the only again purpose of it. Okay, not to connect with any other system or any other device. Okay, so APIPA IPs are to indicate your system is not retrieving an IP from both manual and automatic methods, and we have to resolve that at the earliest. Okay, so these are the two special IPs that you have in IPv4, both of them used for troubleshooting. Okay, so that concludes the whole networking class, guys. There's nothing further to talk about in networking. Oh, there is one small thing. I'm so sorry. There's something called CIDR. I will discuss this in the Linux commands class anyhow, because this is something used in Linux operating systems, an alternative for subnet mask. Okay, but again, let me just give you a brief introduction to this. So this is actually the alternative for subnet mask in Linux. Okay, sometimes you see IP addresses with a number in the end with a slash. So you see something like 192.168.0.10/24. So this slash number is called the CIDR notation. This is indicated by the number of network portion bits. So in class A, when you have one network portion with 8 bits as one, for that the CIDR is /8. For class B, when you have two network portions, they are 8 plus 8, 16 bits. So CIDR for class B is /16. And for class C, when you have three network portions, 8 plus 8 plus 8, that gives you /24. So this indicates that this is a class C address. 192.168.0.10/24 indicates that this is class C. Okay, so this is just a representation of both IP and the subnet mask in one single line. Okay, you first specify the IP and then specify the prefix length. Prefix length is the number of bits in the network portion. Okay, and that number indicates which IP belongs to which class. 8 is class A, 16 is class B, and 24 is class C. So this is how you represent IP addresses and subnet mask in one line. And this is widely used in Linux operating systems, guys. Okay, not in Windows, more of a Linux representation. Okay, so yeah, this concludes the whole networking chapter. So again, from the very first day, guys, from Monday, what we have learned is we learned about IPv4 addresses, where we talked about what are, again, the ranges of IPv4 addresses. How do you convert any number from binary to decimal? What are the categories of IP addresses, classes, public and private IPs? And then we learned about some important protocols. What is subnet mask? What is, again, a DHCP server? What is a DNS server? Okay, how do you assign an IP from a DHCP server and all that? So again, this concludes the whole networking concept. In tomorrow's class, we'll for a change, we'll run a practical session tomorrow, guys. I'll show you how to install an operating system called the Kali Linux operating system inside a virtualization software. So tomorrow's class is going to be much more interesting because it's more of practical implemented topic. Okay, so we'll learn the lab setup installation in the session tomorrow. Okay, so any questions or doubts, guys, before we exit the session regarding networking? Kripa, Lakshmi, Ashish, Adish.
No, sir.
So
No, sir.
I have one question, like this is the regular timing, or in future we may change the class timing?
No. For this batch, it's going to be 7 p.m. itself. Ashish, right, was asking the question.
Yeah.
No change in timing. It's going to be 7 p.m. itself.
Okay, fine.
Sure. Any other questions, guys? It's going to be a class at 7 p.m. So we have a class regularly for at least around 45 minutes to 1 hour, depending on doubts. So if you have any doubts, I usually leave the last 15 minutes for questions. Yeah, Lakshmi, go ahead.
Actual classes will start from Monday onwards, right, sir?
Yeah, these are demo sessions. Again, these are actually the part of the class, but again, as mentioned, only prerequisite concepts for cybersecurity. So once this is done, once we have a good number of students who have registered for the classes, we'll be starting from Monday. The actual sessions from Monday.
Okay. Monday to Tuesday. Monday and Tuesday per week.
No. Only from Monday to Friday, Lakshmi. 5 days a week.
Okay, Monday to Friday.
Yeah, we have classes from Monday to Friday, every day for 1 hour each.
Okay, fine.
Right. Any other questions, guys?
Hi, Arcade this side.
Yeah, Atish.
Yeah, actually, I have joined today only. Can you share the course content or syllabus of this cybersecurity
Sure,
class?
Atish. No problem. You can just drop your email in the chat box, and once I get your email, I'll share the course content with you on your email directly. And again, just to get a much better idea of the course content and the topics we'll learn, You can go back, you can go to this official channel of DurgaSoft on YouTube, and there was a session uploaded on Sunday where we took something called a workshop session. I gave a brief introduction on the whole course and explained what topics will be covered, or elaborating slightly all the topics covered in the course. So if time permits, you can just go to YouTube, search for DurgaSoft solutions, and in that you can search for cyber security. So there have been sessions uploaded from Sunday, whichever sessions I've been taking all this week. So the first session which I took on Sunday was a workshop explaining all the course content. Okay. If not, I'll just share a PDF document as well, which again gives you a list of all the topics covered. Okay. Just drop your email in the chat box, Atish. Any other questions, guys? Any other doubts also? Atish, are you there? You can drop your email in the chat box. I'll share the course content.
Yeah. Yeah.
Right. Kripa, any questions? Ashish, any questions? Lakshmi,
No
any questions?
question, sir. I just have a quick question. I just have a quick question.
Yeah, go ahead, Kripa. I can hear you.
I'm sorry. So you said tomorrow we will be learning about the Kali Linux.
Uh-huh.
Yeah, so sorry, I know my schedule is a bit confusing, but is that what we did last night in the nighttime class?
Again, we learned about Linux commands, Kripa, in that. So as mentioned, there are these two separate batches running. That batch is 2-3 classes ahead of this one. So again, we'll be learning the lab setup installation again in this batch. So the morning batch is 3 or 4 classes ahead of this one. So the classes might be a bit repetitive for you, Kripa.
Okay, thank you so much, sir.
No problem. Right.
Thank you.
Okay, guys. Thank you. Bye-bye, guys. Nothing further for our session today. Please do join tomorrow where we learn the lab setup installation. Bye-bye. Good day.